This is CCNP 2.0 switch. I'm Aditya. In this section, we are going to take a look about spanning tree protocol enhancement or spanning tree protocol feature. If you're talking about spanning tree protocol convergence, a legacy spanning tree protocol may take up to 1 minute time to converge the network. Because of that, Cisco implemented a little bit way so that you can tune your spanning tree protocol for faster convergence. So this enhancement or a feature you can divide into three categories: for faster convergence, spanning tree protocol security, and loop prevention. Obviously, sometime your loop may occur even you are running a spanning tree protocol that I think we have already discussed in UDLT. So no matter, we're going to discuss shortly. But first topic, let's start from faster convergence. In faster convergence, we have option. We can turn particular interface on as a port fast. We can configure switch port host, uplink fast, backbone fast, cross stack uplink fast. So these are the feature that we have. Based on this feature, we can tune the topology for faster convergence or faster transition of layer 2. So first, let's discuss about port fast. What is port fast? Where we need to use, how it's going to work. A port fast itself is a very good enhancement in spanning tree protocol or legacy spanning tree protocol. Actually, it bypass listening and learning state on particular trunk or access port. So first, let's understand why actually required. No matter that device is connecting, your switch is connected with end device, the device is not aware about spanning tree protocol in BDDU. Even then, your switch port going to listening, learning, and then after forwarding. That doesn't make sense. Yes, this is true if you are connected with the switch, but if you are connected with the end host device, that could be laptop, desktop, printer, or IP camera, this is not good. This is not good practical. So the port which is means taking up to 1 minute to coming up for convergence, you can configure that port as a port fast, I should say. So you can enable on trunk port or on access port as well. They're going to bypass listening and learning, as we discussed. So better to connect a workstation or a device which is not aware about spanning tree protocol. If you're going to connect with switches or a device that is aware about spanning tree protocol, that may cause layer 2 loop. So make sure any port that you're going to configure as a work like port fast, that should be in the device or a device that is that is not spanning tree aware. Excuse me. This feature we can apply in spanning tree plus, rapid spanning tree, as well as multi spanning tree protocol. You can enable this feature based on the interface. Either you can enable globally. So what happens if you are going to enable it globally? You need to execute command spanning tree port fast default. So in such case, if you're going to enable it globally, your switch automatically going to figure out which port I need to configure as a port fast, which one not. This is very simple. A port which is listening BPDU message, that should not configure as a port fast. A port which is not listening any BPDU message, not learning, not getting any BPDU message, that means this port is right port which can be configured as a port fast. It also not going to affect your MAC table. So that means, let me discuss little bit more how it not going to cause any MAC address flush problem. In normal situation, what happen, if any switch we connected, let me go through the example. If these ports are not configured as a port fast, suppose, and you may have a switch, other switch and some other switches. As we know, every switch in bridges, they're going to maintain their MAC table on per VLAN. And suppose this port is connected to VLAN 2, if it going to flap coming up and going down, what going to happen? Your switch going to generate topology notification messages. So that means it going to send topology notification message out of every switches. Immediately every switch is going to flush their MAC table regarding the VLAN. Means whatever MAC table they are maintaining in VLAN 2, they are going to clear out. So that may cause unnecessary unknown frame flooding. Since they have not any kind of layer 2 MAC addresses on VLAN 2, so if they receive any frame, they are going to perform frame flooding, that we know. So we also take care about that. If we running legacy spanning tree protocol and any link going to flap, that may cause the layer 2, not that may cause frame flooding, not loop actually. So this is better. You can apply those port as a port fast so that they are not going to flush out the CAM table of all switches in your network. Shortly we will go through the practical that make lot sense. Before going practical, let's discuss couples of things, and rest of, I should say, the rest of topic. Either we can enable switch port host. A switch port host little bit means, personally I guess that this is better than port fast. So since no, the port fast going to connect with the devices which is not aware about the spanning tree protocol. So you can also enable particular port as a host port. That means it's going to configure as an access port, that is not going to become a trunk. Obviously port fast going to be enabled, and you cannot combine that interface in channel or a group channel. So that is very good in case of if you going to connect particular port as a laptop, desktop, IP camera, printer or a server. On such way you can apply this setting. You can configure particular ports or group of ports as a switch port host. And we have some other some other topics. Let's go through it. Uplink fast. Why we required uplink fast and what is working of uplink fast. So let me demonstrate a little bit about the uplink fast. So consider if you have a 2 switch and this is a bridge, root bridge. So your switch going to figure out which port going to become a root port and which one is the alternate. This is how your spanning tree protocol going to work or working every time. But you know what happen if somehow someone taken out this cable or this link goes down? These ports again going to listening, learning, and then after forwarding. That doesn't make sense. If this switch already know the route is available via this link, so why it taking so long time for convergence? So you can mark this port, either you can run globally this command to make this interface for faster convergence. If your root port going down, your alternate port going to bypass listening and learning, and it immediately going to become root port. But make sure this feature is only supported by Spanning Tree Plus or the Cisco proprietary Spanning Tree algorithm. So this is actually detect direct failure. In the same way, your backbone fast, let me show you backbone fast going to work out. The backbone fast and uplink fast is working as the same, but the difference is that your backbone fast is not going to detect direct failure, it's going to detect indirect failure. So that means, suppose this is a root bridge, and this port going for root switches. That means this is the root port. What happen if this switch goes down or this interface goes down? You have an alternate link toward your root bridge, but even then you are going to listening, learning, and then after forwarding mode. So if you have enabled that feature, you are going to immediately detect that problem in marking this interface to up. That means you are not going to wait longer time for convergence. And so on. If you're talking about the cross stack uplink fast, this is actually usage on gigabit stack. So gigabit stacks actually kind of uplink ports that goes from one switch to another switch, and there is a restriction they are going to support in such models only. So uplink fast, I find that uplink fast, or you can say uh, uplink fast and cross stack uplink fast is the same thing. The difference is that is going to work on gigabit, and you should have special switches or a special model of switches. They are going to work on that way. You can go through the line, and that makes sense a lot. So first we need to configure this feature, and we need to verify this feature. Then after, we are going to discuss about spanning tree security. So let me turn my devices on. Alright, my device is up and working, and let's verify about the working of port fast. So what I'm going to do, this is the topology that we are going to work with. We have switch 1, switch 2, switch 3 and switch 4, as we can see the connectivity as well. And additionally, switch to gig 0/1 is going to connect my production network. And let's see the currently MAC table of VLAN 1. So I'm going to execute same command out of every switches. So MAC address -table, which is learned dynamically for VLAN 1. We can see we maintaining up to 11 MAC address on VLAN 1, switch 1, switch 2, switch 3 and switch 4. Most of they have almost the same MAC addresses. So what I'm going to do, I'm going to turn this interface off and then on. So on switch 2, configure terminal, and let me verify this is going to connect with my production network or not. So hopefully it is. Yes, we can see gig 0/1. So interface gig 0/1 shut. So I'm turn that interface off, as we can see there, and let's verify the MAC table out of every switches. So obviously it's going to flush out not only switch 2, in fact switch 1, switch 3 and switch 4. All they going to flush out the CAM table, and they actually created some MAC address because of the MAC address associated to switch itself. This is also the problem if any port going to turn off and on. So let me bring it up. So interface gig 0/up, and then after no shutdown. What I'm going to do with this port, I'm going to turn or configure this interface as a portfast. So let me execute command spanning tree port fast, and then we have some other option also. We can disable interface if it already configured as a portfast, or if we going to press enter, it's going for work with access port only. And you can also specify with the trunk port. For my case, this is access port, so I'm not going to enable as a trunk port. So let's again see whether we have already created CAM table or not for VLAN 1. So same command I'm going to execute, and let me forward some packet toward my network 192.168.1, 2, 3, 4 and 5, 6, 7 and 8. 100 is my laptop itself, and last one is 205. Right, so if we executing same command, that was MAC address table for VLAN 1, which we have learned dynamically. And again I'm going to turn off that interface on switch to interface gig 0/1 shutdown, and let me execute same command. We can see rest of switches, they actually not going to flush out their MAC table because they are not directly affected with that port. So this is how advantage that going to add in your network if you going to turn on particular interface as a port fast. You can also enable it globally, spanning tree port fast, and then after default. So in this case, your switch automatically going to figure out which port I need to configure as a port fast, which one not, because you know very well, based on the receiving the BDDU message, it going to work out. So let me turn this on out of every switches and paste. Excuse me, I need to paste right there. Right. So this is the way that we can enable port fast. So it could be a trunk port or access port. We can enable and globally as well. So let's talk about little bit about a particular interface that is going to connect with the host, or an interface that we can tune as a work like switch port host. And this is not actually feature of a spanning tree protocol, but here I am going to talk with it for it. So interface gig 0/1 port, I think the command is not switch port host. So if I am going to turn this on as a host port, it's going to automatically enable this interface as an access and port fast, and going to disable Ethernet channeling or link aggregation. So you can also configure this one. And about uplink fast. So let's verify how your uplink fast going to work with. First, let's show which one is working as a root. So I'm going to execute command out of every switches, do show spanning tree. We can see switch 4 is a working as a root bridge. So let me bring up my paint. This device working as a root for VLAN 1, 2 and I think all. Let me see. VLAN 1, VLAN 2 as well as VLAN 3. That's great. So if it working properly, we know very well F0/2 port going to become a root port, and F0/3 will work as a alternate. So let's figure out it's working or not. This is on switch 2. On switch 2 for VLAN 1. So let me this time execute only for, excuse me, do so spanning tree, excuse me, spanning tree for VLAN 1. VLAN 1 only. So we can see F0/2 is working as a root, F03 is an alternate port. So what happen if F0/2 going to turn off, or somehow your plug going to take out from the network or from the switch? So interface F0/2 shut down, and let me execute command so that we can verify. F0 is become root, but it's listening right now. Listening again. Listening, learning, even learning we can see. So it may take up to 1 minute for listening, learning, and then after forwarding. You can avoid this outage of your network just turning on the port uplink fast. So let's verify it's working or not. Now it's working as a forward state. So I'm going to turn interface on and going to execute command on globally out of every switches spanning tree uplink fast. So let me copy this command so that I can execute out of every switches. Paste and paste. Excuse me. Now I can paste. That's great. And let's figure out, let's see or verify, I should say, the transaction speed or convergence speed. So again, I'm going to use do so spanning tree for VLAN 1. Excuse me. We can see F0/2 is working as a root and F03 is an alternate port. Sorry. So I'm going to turn off interface F0/2 shut, and let's see. We can see right there immediately for uplink fast that we have enabled. Based on that, interface F0/3 move to forwarding. Let's verify using the command forwarding. So it's working as a root and working in forwarding mode. This enhancement can be applied to your network so that we get faster convergence. Similarly, we have a backbone fast that is not directly going to detect out but indirectly. So how we can enable, by the way? Let's see what will be the command. Exit spanning tree backbone fast. Same command I am going to execute out of every switch. Copy, paste. So they are going to converge fast. Excuse me. Configure terminal and then after paste. I'm not going to configure cross stack uplink fast, but yes, I want to show you how we can configure that interface or that feature. So for instance, this time I'm going to select gigabit interface gig 0 slash, sorry, this is switch 2, interface gig 0 slash 2 spanning tree, and let's say we have an option stack port. So we can enable this interface as a stack port in order for faster transition. The next thing that we are going to take a look about spanning tree security. So sometime you are worried about your network security, maybe because of misconfiguration, because of preventing the hacking inside your network. You can enable this feature like BDDU filter. If you're going to enable BDDU filter, that means interface, that particular interface not going to send neither receive BDDU messages. So that means on that particular interface only and only host can be connect, and any switch if going to connect, that is not going to send or receive any BDDU message for security reason. Similarly, you can use BDDU guard. In BDDU guard and BDDU filter actually working the same way, and different is that BDDU guard immediately going to turn that interface off, means pulling your interface as error disable mode immediately if any BDDU message is received. So if any on particular interface, if you have enabled BDDU guard, that means if any BDDU message is received by that interface, that is immediately going to turn off. And last thing is that root guard. Root guard is working little bit different, and that's I need to explain little bit. Suppose we have a switch 1 and switch 2. This is working as a root bridge. This is port 1 and port 2. So by default port 1 going to become as a root port, and 2 will work as an alternate. And somehow that you don't want to this port going to work as a root, you can enable this interface, on this interface root guard. So that means this interface not going to become a root port. So it also you can say that if you have a core layer switches, distribution layer switches, and then access layer switches. Let's see. You know this core layer switch is working as a root. So this port at direction of your access layer should not able to be the root port, because the root bridge is located facing upside. So this port should be become root, this one not. In such case you can also enable root guard. So let configure BDDU filter and BDDU guard. So same, I'm going to use switch interface spanning tree guard. What you like to guard, spanning tree guard, what we looking for? Sorry, this should not be guard, this should be spanning tree, and then after BDDU filter, right there, BDDU and filter. That means enable. That means this interface not going to send or receive any BDDU message out of this interface. Similarly, now take a look about BDDU guard configuration and verification. So we have discussed any interface that is configured as a BDDU guard. Whenever it receive any BDDU message, that going to mark that means configure that interface or pull that interface in error disable mode. And let's see on topology. So what I'm going to do, I'm going to configure F0/2 as a BDDU guard, since they are sending BDDU messages and receiving as well. So that port should be put in error disable mode. Spanning tree, spanning tree BDDU guard, and then after enable. So we can see immediately my interface pulled in error disable mode. You can also verify just using command do so interface status error disable. Excuse me. So interface status error disable. There it is. Interface F0/2, the status is error disabled, and then reason is BPDU guard. So because of this interface receive BPDU messages, that's why it's means going to block. So now first let me select the interface F0/2, and then after no shut, and then no shut down. You can also configure to recovery time, but I'm not going to do on that way. The next thing, let enable root guard. So these things I'm going to enable. Currently we know very well interface F0/1 is working as a root, excuse me, this one working as a root port, and this supposed to be alternate. Let's verify on switch 3. Switch 3 do so spanning tree for VLAN 1. So F0/1 is working as a root. F02 is a designated, sorry. So if let me show on some other switch. Can I configure it on switch 1? I think yes. So let me do so spanning tree for VLAN 1. Yes, F0/1 is a root port and F0/2 is an alternate. So this is currently working as a root and this one is working as an alternate. So what I'm going to do, I'm going to mark this interface that you are not a root port, means going to enable root guard on that interface, so that we will see this interface going to become root port. So let me configure on interface F0/2 spanning tree BPDU, excuse me, this is not BPDU, this is let me see what we're going to discuss. Root guard spanning tree, and then after guard, what we're going to guarding? Root. So on switch 1 I configure interface F0/2 as a root guard. So let's verify it's working or not. Do so for VLAN 1. Exactly. As we can see now, F0/1 that is facing down is working as a root port. So now this is time to discuss about loop prevention. In loop preventing, we can enable spanning tree loop guard in UDLD. And little bit we also need to know how they are going to work, or in which situation your spanning tree not going to work. So you may have a 2 switch and you may connect it with optic fiber cable. So one is going to send the data, another going to receive data. Similarly, you have a redundant link. So suppose this link going to become active because we have a 2 interfaces goes to the direction of root. So this is working fine, happy. On this interface we sending BPDU hello messages out of both of interface, not means actually this is the single interface, sending as well as receiving out of every 2 seconds. So this switch is considered that if I am receiving BPDU messages after every frequency, that means everything is fine. But what happen if somehow someone taken out cable from the switch, means the receiving packet, sorry, the receiving cable, That means this switch going to figure out after couples of seconds, if I am not receiving any BPDU message out this interface, that means I should mark this as a forward port. That means I can forward that data out this direction. So that may cause the problem. So this problem can be prevented using spanning tree loop guard in UDLD that we have discussed already. Obviously, the UDLD and spanning tree loop guard, they may work different. You can follow this URL. So some of feature that going to apply with loop guard and some of may not. And some of feature that working with UDLD that may not work with loop guard, as we can see. So let's see how we can enable loop guard and UDLD on switches. So in this time I'm going to globally spanning tree and loop guard. Loop guard default, either you can configure I think on particular interface as well. Let me see uh, the spanning tree guard, and then after what loop. You can enable based on particular interface or you can enable globally. Similarly, you can enable UDLD on interface port. So these two things you can also apply if you looking to prevent layer 2 loop. If you have any kind of problem regarding you may have a optic fiber cable connected to your switches, or you may have a cable, maybe this is UTP cable, and somehow the sending wire is not working but receiving wire is working. So this is all about this. Thanks for watching.